Hello everyone, in today's video we're going to talk about stretching and compressing functions. So we have two types of questions here. This first question here says graph the equation shown below by transforming the given graph of the parent function. On the screen we have graphed for us already y equals the cube root of x. That's the parent function. But they don't want us to graph that, they want us to graph y equals 1/2 times the cube root of x. So a rule, and I'm going to throw it up on the screen here. If the entire function is being multiplied by a value, you don't change the x values at all. You just multiply the y values by that number. So what I mean by that is, let's look at this point 8, 2 here. Don't change the 8. 8 is the x value. We're not going to change the 8. But we are going to change the 2. We're going to multiply the 2 by 1/2. So that's going to move this dot from 8, 2 down to 8, 1. Let's double check that we did everything right here. This dot used to be 1, 1. And remember I said don't change the x value, so it's still going to stay as a 1. But the y value is going to get multiplied. So it used to be 1, now it's 1/2. So you can see multiplying by 1/2 here compressed this graph to be smaller, shorter, right? Let's submit our answer here. Correct. Let's do one more example like this. Same setup. We're going to multiply this whole equation. Y equals x squared is the parent function, and that's what we have graphed here. But we're going to multiply it by 4. So same rule. Don't change the x values, just change the y values. So I'd love to do this dot here, but if I don't change the x is 3. If I multiply y by 4, I'm going to get 36. That's off the graph too far. So I need to go to a smaller value. I need to go way down here to this 1. So don't change the x value, so x is going to stay 1, but the y, which used to be 1, is going to be multiplied by 4. So this dot is going to become 1, 4. So you can see that multiplying by a number greater than 1 is going to stretch this graph, or I should say compress this graph. All right, the other type of equation you might get looks like this. In this situation, the number that's multiplying isn't happening to the whole function. It's only happening to the x. It's happening inside of the operation, right? So in this case, let's look at the graphic that I've put up on the screen here. If you are only multiplying the x value, don't change the y's, leave the y's alone, and multiply all the x's by the reciprocal. So the reciprocal, remember, is the upside down version of the number. So if in this question 1/4 is what we're multiplying by, we're going to take the reciprocal of that, which is 4. We're going to multiply all the x values by 4. So let's look at this dot here. Don't change the y value, so don't change this 2. This dot is going to stay on y as 2. But we're going to multiply the x value, 8, by 4, which is 32. So this dot's going to go way off the screen. So we need to do a dot much closer. Let's do this 1, 1 dot here. So we're not going to multiply the y. So we're going to leave this dot lined up on the y-axis with 1. But we are going to multiply the x by 4. So that's going to move this dot right there. Okay? So you can see the difference of what these problems do based on where the multiplying is happening here. So one more example for you here. This parent function is y equals 2 raised to the x power. The 2 is part of the parent function, and so is the x. But now we have a 1/3 in there. That 1/3 is only happening to the x, which means we need to follow the rule of don't change the y values and multiply x values by the reciprocal of 1/3. What is the reciprocal of 1/3? It's 3/1, or 3. So let's pick this dot here. Don't change the y value, so don't change this 2. We know this dot's going to stay lined up with the 2, but multiply the x value by 3. So now instead of 1, it's going to be a 3. So there we go. All right, before I leave, I'm going to make this graphic that I have here full screen so you can get a full view of it, and you can maybe screenshot it or take notes or take a picture or whatever you want. So that's all for today. Thanks for watching.